Group 4 kayo, no? 4? 4. Okay.
Good afternoon, class. May we all stand up for our fourth prayer? Any volunteer to lead our prayer? Okay, Axel.
Dear God, thank you for this day. Help us understand our lesson and protect everyone in this class.
Before you take your seats, may we check our area and pick up any pieces of paper or craft and also arrange your chairs. Thank you. You may now sit down. Again, good afternoon, class. Oh, I think our energy is a bit low today. Let's try it again. Okay, that's how I like it. I hope everyone is doing great today. Who's the secretary? Hey, Angel. Is anyone absent for today? Yes, teacher. On board, Okay, thank you. That's noted. So today, we're gonna take a review of our classroom goals. Let us read it together. So is that clear, class? Today, we're going to use an incentive chart from Jessica to Angel to be Group 1 and from Axel to Matt to be Group 2. Every time you participate, you show good behavior, you answer correctly, your group will earn points. So, the group that has the most points or the group that completed their rehab chart will receive a reward after our class. That clear? Okay. So, do you still remember our previous lesson a glass with water, and I place a spoon in it. So observe what happened to the spoon. Okay, everyone? So what do you notice to the spoon when it placed in the water? Okay, Louis.
Looks like it's broken.
Okay, everyone? Everybody? Good job. Okay, it's broken, it bends. What else?
The spoon looks different because of the water.
Okay, the spoon looks different because of the water. Anyone? Anyone? Okay, that's a very good observation. So, the spoon seems broken because light changes direction when it passes from one liquid to another, just like from air to water. So, that is why it seems like the spoon is bent or broken. Okay. So today we will explore this behavior of light in lenses. We will do a group activity. So I will distribute the materials and procedures. So this lesson, this is briefly explained, but in your envelope there is a detailed procedure of what you do, So first is choose a safe working area. Okay? Prepare the materials, place the one paper on a flat surface, lay the lens A on top of it, position the laser on the left side of the lens, then switch it on, choose one number to present your output, answer the table on the cartolina provided, answer and discuss right questions with the group, repeat the procedure using lens B, and lastly, observe and record how the light behaves, repeat the procedure using lens B, answer and discuss the right questions with your group, answer the table on the cartolina, and choose one number to present your output. So, when you lose a precaution, when you lose the laser, don't point it directly on the eyes. And also, use the laser on a dimmer place. So, I guess we need to close the window. So, okay, you have 10 minutes to finish the activity. Okay, 3 minutes left. Okay, 2 minutes more. Oh, I think you have one has given Okay, group one done, and then we open the windows. And the lights. Group two is just writing your observations na lang. Okay, tapos na rin sila. So the first group, the minutes there. Task, first is the group one of teacher as teacher. Okay, now, let's call on the representative of Group 1 to discuss their observations.
Okay, good afternoon, classmates. Good afternoon, teachers. So these are our observations from the activity that we performed. So we had two types of lenses. For lens A, we noticed that the shape has thin edges and it has a thick center. While on lens B, it was the opposite, where the center is thin compared to the edges that are thicker. And then, when we shine the light, this is what we saw. We sketched what we observed. And we observed that in lens A, the light rays move inwards or meet at a point, just like what we do here with the sketch. And on the lens B, the opposite happened. The light rays actually spread outwards and did not meet at a center or a point. That is all. Thank you.
Okay, very good. Let's give a clap for Group 1, amazing clap. So, 1, 2, 3, 1, 2, 3, zing, 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 amazing. Okay, now let's do it together. 1, 2, 3, 1, 2, 3, zing, 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 amazing. Now let's call on the representative of Group 2.
Good afternoon, classmates. Good afternoon, teachers. It's the presentation of Group 2. So, while performing the activity, we noticed that both of these two lenses are very different because from what we observe on lens A, the center of lens A is thick and its edges is straight, while the opposite can be observed on the lens B because the center of lens B is thin and the edge is thick. For the observation of the light, we notice in lens A, the light converges at a certain point, so parang the light starts to converge at activity, we can observe that both of these two lenses are very different from each other.
Okay, very good, group two. So everybody has given their insights and observations about lens A and lens B. So lahat kayo may idea na how light behave on concave and convex on the two lenses. So let's give a nice talk to group two. So 1, 2, 3, 1, 2, 3, nice. 1, 2, 3, go.
1, 2, 3, 1, 2, 3, nice!
Now, class, since you're done with your activity earlier, let us answer the right questions that you had in our activity. Now, since you have already done your activities, now who can tell me what happens to light when it passes through lens A? Anyone who would like to answer? Yes, Mr. Garcia.
When light passes through lens A, the light converges at a certain point. You can see in the image, three light, different light, or they converge in a single point.
Yes, that's right. So the light rays in lens A, it forms a converge, or the light rays meet at a specific point. While in lens B, the light rays spreads outward, or it diverges. Now, for our next guide question, how about what happens to the light when it passes through lens B? Anyone who would like to answer? Yes, Mr. Alta.
The opposite happens from lens A because on lens B, the light rays actually diverges, meaning they spread out or spread apart.
Yes, that's a very good observation, Mr. Rona. So as I said earlier, in lens B, the light diverges. Now, what do you notice about the differences that the two lenses form light patterns? What can you say, or what have you observed about the differences of the light formation of the pattern? Yes, Ms. Rodina. And let's say it forms converging patterns since the light meet at a certain point, where in the lens B, it forms the diverging pattern where the light spread out. Yes, great answer, Ms. Rodina. So let's say it forms a converging pattern, while let's B forms a diverging pattern. Now, what do you notice about the shapes of each lenses? Can anyone describe the shapes? Yes, Ms. Aleni. So for lens A, it has a big center, and it has a thin edges. While for the lens B, it has a thin center and a big edge. Yes, that's right. So I think what groups answered the same thing for the shapes in your activity based on their centers and based on their edges. So lens A has a bigger center, while lens B has a thinner center. In lens A, the edges are thinner, while in lens B, the edges are thicker. So based on their shape and how they affect light, or how they form light patterns, what do you think is the type of lens A and lens B? Yes, Mr. Garino.
Lens A is a convex lens, and lens B is a concave.
Very good. Now you have identified what type of lens you have used or done in your activity. That's right. Now lens A is a convex lens and lens B is a concave lens. Although they have different shape, but they are still the same concave lens. These two are concave lens. So now in this part of our lesson, let us tackle more or delve in further to our lesson, because we will be tackling about image formation in both the convex lens and concave lens. Now, in order for us to understand this topic, Now, in order for us to know if the image form is real or virtual, real image is where light rays actually meet at a certain point, while for virtual image, they do not meet, or they only appear to come from a point. So later, you will understand how it is or how it happens in this topic, and to identify if the image is inverted or upright. So when the image is real, it is always inverted or upside down. While for virtual images, it is always upright or erect. While to know the size of the image, we will have to know or understand where is the object located in the illustrations. So, further understand this, we must remember there are three parts for each equation. So this is called the optical center, and this is the focus, and this is the twice the focal length. Can anyone repeat what I said for the parts? What are the three parts? The first one, what is this? Anyone? Raise your hand. It's okay if you So this in the middle is called the optical center. While for this, okay, Mr. Garcia.
It's focus and 2x twice the focus.
Yes, that's right. This is twice the focus or twice the focal length. Now, since we have guide here and you are already familiar with the parts, we can now determine or know what type of image is formed in this each situation. Now let's go first to convex lens. So if the object is beyond the twice the focal length, so as you can see in the picture, it is beyond or it goes out of the twice the focal length, the image formed is real and inverted and diminished. So since it is a real image, it is always inverted since as you can see in our guide, and since the object is located beyond the 2f or twice the focal length, the image is smaller or diminished. Can anyone again explain why is it real and why is it inverted and diminished or smaller? From your own understanding. Anyone? Based on these guides or tips. Anyone who would like to try? On why is this real? Why is this inverted and diminished? Okay, so I will be the one to repeat what I've said earlier so you can further understand. So the image is real because it meets or it intersects at one point. Yes, since it is a real image, it is always inverted. So if it's real image, it is inverted. While it is diminished or smaller image compared to the object because the object is located beyond the twice the focal length according to our guide. Okay? So can anyone explain to this equation based on our guide? So if the object is at twice the focal length, it is exactly at the twice the focal length. Based on this, so why is this image real, inverted, and the same size? Anyone based on this, guys? Okay, Mr. Garcia.
What I noticed on difference is the image is now in the same size because the object is located precisely at the twice the focal length, and because it's located there, therefore the image is in the same size.
Okay, very good. That's right, Mr. Garcia. Now for our situation number 3, if the object is between twice the focal length and the focus. So if it is between, what is the image form? Yes, Ms. Laurie?
Bigger image.
Yes, it's real.
The image is real since the light rays hit, and if the image is real, it is
And since it is inside the opus, it becomes bigger.
Yes, that's right, Mr. Garfield. Since, as you can see in our picture or illustration, the image is not formed here since they do not meet, but you can only trace them backward, and this is where they intersect, so the image is at the same side as the object, hence the image form is virtual. And since it is virtual, it is always upright or erect. And it is also bigger image than the object, since as you can see from the blue color, this one is the object and the image form is much more bigger than the object. So we are done now with the image formation in convex lens. Now we will go to the image formation in concave lens. Now, since the image formation in a convex lens varies or they are different depending on the location of the object. So now in this concave lens, no matter the location of the object, the image form is always erect or upright. It is also virtual and smaller or diminished in size. So did everyone understand our discussion about the image formation in convex and concave lens? Yes, that's very good. Now, to further ensure that you have learned something, let me ask you some questions. So, what are the two types of lenses and how do they differ in shape? Yes, Ms. Aleki?
So the two types of lenses are convex and concave lens. And the difference is convex lens has a inner center while the other one has a inner center.
Yes, very good. So, the two types of lenses are concave and convex. So, they differ in shape because convex lens has bigger center while the concave lens has thinner center. Well, how about what happens to the light when it passes through each lenses? Yes, Miss Rodina?
In convex lens, the light converges while in concave lens, the light diverges.
Yes, very good, Miss Rodina. Now, lastly, how do the images form differ in convex lens and in concave lens? Anyone, Mr. Garcia?
What I noticed is that the image formation in concave lens is always virtual no matter the distance, but in convex lens, the image can be real or it can even be virtual depending on the distance of the object.
Yes, very good. That's right. Now, the image formation in convex lens, they may vary and they may be different in terms of their size, if they are real or virtual, or if they are inverted or upright, depending on the location of the object. While for the concave lens, it always produces an erect, virtual, and smaller image in concave lens. Now, since I am sure that we have acquired the needed knowledge and skills to do our next activity, let us now apply your knowledge and skills into our next activity. So now you will working with the
Next group. It's fine. Go.
Bye.